Hey everyone, today in this video, we are exploring Kubernetes scheduling, the intelligent system that decides where your pods run in a cluster. We'll start with the basics like when you might manually assign pods to nodes and why you would normally let the scheduler handle it. Then, we will get practical with node labels and selectors. We will show you real kubectl commands to check scheduling decisions and much more with hands-on examples. So, let's get started.
We are going to talk about a very interesting topic, that is scheduling. How to schedule your application and how to work with the scheduling part, and how the scheduling will help your application to run in very smooth way, so that we can consume the resources as much as possible. And this approach help your traffic to maybe consume or maybe utilization, optimize the resource utilization, if you know how the scheduling works, to get a better performance for your application in the distributed system. Yes. So let's talk about the scheduling, and so let's work with let's learn how the scheduling work and how these things works. So yes. So now, before getting started, let me show you the pictorial view. Maybe let me draw, and Excel I draw. Yeah, let me go with this picture. Okay. Yeah. Okay. Assume that we have one cluster. We have one production grade cluster. Production grade cluster. In the production grade cluster, so we have different nodes. This is my node 1. Okay. This is my node 2. Node 2 in the sense, maybe node, you know the concept. Node is nothing but the servers, machines. Node 3, node 4, node 5, node 6, node 7, node 8, node 9, node 10. We have 10 node cluster. 10, 9, 8, 6, 7, 6, 5, 4, 3. Yeah. So this is my production grade cluster. And so now I'm deploying one application. So now in this scenario, I have maybe multiple nodes, different nodes. And I have segregated my nodes based upon the functionality. So I have one node to run some specific application. So to run some business critical application. So here I just want to see the business critical application, business critical hyphen app, business critical application. Okay. So I have created node, and in that node I have all the configuration. So I have configured host path. In that host path, I have configured all the configuration, all the sensitive data, all the environment variables I'm passing from that host. So for that reason, I need to ensure this application need to get scheduled to this specific node only. At any cost, I want to ensure this application to be get scheduled on node 10. Why? Because so if I schedule this application on node 9, it may won't have any configuration. So it may go for pending state, some config error, something. So for that reason, I need to ensure this application to be running on node 10. How to tell? How to ensure? How to tell my API server, hey, schedule, or maybe talk with scheduler and ensure this application to be running on node 10. So what is the solution? How to take a decision? So here, what is the job of a scheduler? We have API server, which will ensure maybe every communication must and should go through the API server. And we have another component called scheduler. So what is the job of scheduler? When you deploy any application, the scheduler is the guy who will help you with node name, and based upon that help, the API server will schedule your application on that node. Am I right? This is how the things works. Yeah. So now here I know the node name. I know I want to schedule my application on node 10 only. Here, what do you think? Is there any role of scheduler? Because I am specifying the node name on which node I want to schedule my application. I know I want to schedule my application only on node 10 at any cost. So here I want to bypass this scheduler because I know the node information. Here I don't have any role of scheduler to schedule my application on node 10 only. So how to tell API server? So if you want to, this is called manual scheduling. If you want to schedule your application based upon your decision, if you want to bypass the scheduler, in that scenario, we have a way, we have a concept called manual scheduling, where you can schedule your application by specifying the node name. How? Let me show you the YAML kubernetes.io. Here, manual scheduling. So in the YAML manifest, so the YAML manifest is like quote order, and so what you are supplying, it is the strict order from the user to API server. This is what how I schedule, how I want to schedule my application, what are the environment variables I want to supply, all the stuff I'm going to add in the YAML. So we consider our YAML manifest is like quote order for API server. If you specify the node name in the quote order itself, by using this node name flag, we supply the node name on which node we want to ensure that application to be running at any cost. So now let me go and copy this YAML and 20. Yeah. So kubectl get nodes. Yeah, I can get to see all the nodes are running. So vim pod dot YAML or bc hyphen pod dot YAML. Okay, here escape set new and insert mode. So now here I deploy, I name it this application as BC pod business critical pod, and the image is HTTPD. Okay, I want to schedule this application. Please ensure API server. So this application to be running on. So what are the node names we have? Cube node 2. I'm just specifying the node name directly. Let's see what will happen. So now, hey kubectl apply -f. The name of the pod is this. The YAML name is this. Created. Now if I go and check, hey kubectl get pods -o void. What do you think? In this scenario, the BC pod got scheduled on node 2 based upon our request. So let me delete kubectl, delete all -all to avoid any confusion. So let me redeploy that application again. Kubectl apply, and now I want to ensure that application on node 2. If I see that application on node 2, the meaning of that is it is preferring my decision. So here, what do you think? Is there any role of scheduler? Hey kubectl describe. How to know? Hey kubectl describe pod, and the name of the pod is bc-pod. Can you get to see in the events? There is no rule of scheduler. If you deploy simple other application, hey kubectl run app1 -image is equal to nginx. So in that scenario, hey kubectl get pods -o void. Okay, Can you get to see the app1 got scheduled to node 1? When you describe that pod, hey kubectl describe pod, and the name of the pod is app1 comma bc app and grep -i events. Okay, let me search. Okay, so no, I think describe won't support 2 times. So grep pipe it, grep -i events. Let me describe first. No, app1 rather than comma. Let me go with this. Yeah, it's working. So now let me grep for -i events for both. Yeah, show me -a hyphen capital A 5 lines. So now can you get to see here? So this is this event related to HTTPD image, which is manual scheduling, where we specify the node name. And this is, so I deployed my application like how we deploy kubectl run. Here I don't tell where I want to schedule my application. I just relied on the scheduler. Can you get to see here? So while events, so the first thing is there is a role of scheduler, but here in this scenario, when you supply the node name, is there any role of scheduler? No, because so you are bypassing the scheduler by using an instruction called, by using a flag called manual scheduling. Okay, if you want to take any decision in sense of scheduling, you don't want, you know where to schedule. In that scenario, you can go with this type of scheduling. But what is the drawback with this kind of scheduling? So now you schedule your application on node 10. Everything is fine. Everything is going smooth. So for some reason, if this node goes down, if this node goes down, what do you think in that scenario? Because you have hard coded the node name in the YAML, the API server will try to run your application on that node only. But the node is not available. What will happen to your application? It gets scheduled to here. No, it get to schedule to here. No, and it will be in pending state. It will just waiting for maybe the node. So the API server, so I have other nodes, but you have hard coded that name, you have supplied that stuff by using the quote order, the YAML manifest, and for that reason I have to ensure that pod should be running on that specific node. Your application will be in pending state and you end up having a single point of failure in this type of scheduling. But which scenario, what is the scenario I can go with this type of scheduling? So if you have any maybe the business use case where you need to ensure your application on that specific node, or where you will ensure the availability of that node, in that scenario you can go with this type of scheduling called node name. Okay, so in this scenario there will be no role of scheduler, you need to ensure, and you will need to know you are bypassing the scheduler and you are taking your decision, you are adding a direct affinity. So this is what the attraction, so this is where I want to see my application, so I will ensure the node availability and please schedule my application, please run my application. Yes. Okay, fine. But Mudassir, so we are, by using this type of scheduling, we are defeating the purpose of Kubernetes. Here, we don't want to see our application to be in down state because of this reason, because we are going with just single server. And if I want to have, maybe I am running on database and I have configured maybe 4 nodes with the same configuration to run some specific application, some specific database. Okay, MongoDB. Okay, so here node 6, node 7, node 8, node 9. And for some reason, if node 6 goes down, I want to see that application to be running on node 7. If something happened to that, on node 8, if something happened to that, node 9. So how to ensure that this type of scheduling? Okay, here you need a help of scheduler, and you need to tell scheduler, hey, rather than, because you can have one node maybe name. So in this scenario, Mudassir, why can't we specify in the YAML manifest two node names? If something happened to that node, go to this. Is that, what do you think? In that scenario, can I go with that method? Where is that? What is the name of the bcpod.yaml? So vim bcpod.yaml. So here, Mudassir, you are specifying one node name. Why can't we specify more than one? Cube node 2 or cube node 3, cube node 5, cube node 10, like that? No, it just support one at a time. You specify 10, that is doable, but it will take just one. The last line of the node name you can add like this. Okay, maybe escape 1 yy escape p. You can add maybe the node name. Yes, it get created, but it will take the last line. It will consider the last line for scheduling your application. The API server will support only one name at a time. Okay, fine. So now let me show you that as well. Maybe if I go and tell BC, now BC pod, maybe or demo. Here I'm in the last I'm specifying one. Let me go and apply WQ exclamation. So now here, hey kubectl apply -f created. Where it got scheduled? Hey kubectl get pod, and the name of the pod is demo, and -o wide. Where it got scheduled? The last node name what we had added. So it just prefer the last line, and it will schedule your application on the last node name if you have added multiple nodes. Yes, but how to have multiple solutions? So rather than going with the node name, if you want to have maybe multiple solutions, so in that scenario, we prefer to go with labels. So here we try to attach labels. Team is equal to asim. Team is equal to asim. So this is the label I ensure on all the nodes, and while scheduling my application, I tell my scheduler, hey scheduler, my friend, please ensure my application to be running on the node having a label team is equal to asim. So now if something happened to this node, it automatically gets scheduled to this node. Till the time you can troubleshoot that node. If something happened, yes. So this is how we will ensure we will avoid single point of failure my database by running my application on different nodes by using labels. But how to supply this information? So that's where we have a concept called node selector. I need to ensure a flag called node selector, and I need to specify the label team is equal to asim, any key value, anything is fine. So now let me go copy this YAML, vim pod.yaml. I'm just adding this. Okay, my Mongo pod, and the name of maybe the container is C1, and the labels node selector term is ensure my this Mongo pod gets scheduled on team is equal to same. Let me save it, and now let me apply it. Hey kubectl apply -f pod.yaml created. Now if I go and check, hey kubectl get pods -o void, what do you think? What will happen to this Mongo application? For that reason, what is the status you are getting here? Because it is going and searching on the node, but no node have the label team is equal to awesome. So now what will happen? So now on which node you want to see that application, you need to label that node with the same label. So now let me duplicate one session. Ubuntu welcome @1234 and sudo space su space hyphen and watch kubectl get pods kubectl get pods -o wide and the name of the pod is Mongo. Now it is in pending state. Can you get to see here? It is in pending state. Now what I will do, let me label that node. Hey, how to label? Hey kubectl label -- help. So here you will get the option kubectl label and you can use the file name or the name. So to whom you want to label, whether it is a node, whether it is a pod, whether it is a deployment, services, anything you can label it. In my scenario, we are labeling node. Hey, kubectl label. I want to label node. Which node? There is a label. There is a node with the name kube-node1. I want to see my application on kube node1. For that reason, I'm labeling that node. What is the label you want to attach? So the label is team is equal to same. So just concentrate on the screen. So when the scheduler finds the node with this label, it will schedule your application automatically on that specific node. Let me hit enter. Just concentrate on the screen now. Can you get to see the Mongo pod rather than pending? It is in running state because the scheduler find, hey, there is a node. Just now I got that node. The node name is kube node1. Hey, just schedule my application. Yes, you can schedule. The label is matching. So now you can, it will help the API server to get the information regarding the node. Oh, yes. So like this, you can ensure 2 or 3 labels. You can, yes. Okay. So in the node selector, so now I can label, what do you think? Can I label the same label to 100 nodes as well? Is there any restriction? Can I label the same label to node 2 as well? Yes, you can. Okay. Yes, I can label. Next time, the scheduler will have 2 options. It can schedule your application node 1 on or on node 2 as well. So like this, you can ensure your application on maybe specific node by using labels. Yes, in queue, and it will pending in the sense. So if you see the error, the status pending, the meaning of that is the node is not available. So the configuration, what is the configuration you are requesting? Maybe any labels, any requirement, any limits, maybe any stuff you are adding. So if it is not matching, so in that scenario, the scheduler can't able to find any node pending in the sense. So it is just waiting for the node. Yeah. Okay. Fine. So now, so this is regarding maybe the node selector where you will ensure your application gets scheduled on the specific node. So now, if you want some more permutation and here, maybe if your node, if you have node with that label, in that scenario, it will get scheduled on maybe that specific application. So it is kind of a hard rule. Am I right? Unless until the scheduler won't find that label, your application will be in pending state. Yes, but the application is very, very important. But if it won't satisfy, so then also I want to see that application to be in running. I don't want to see that application in down state. I just want to have some permutation combination. So if that maybe the rule failed, I want to have another backup rule. So there is another node. I'm configuring the steps, same stuff on that specific node as well. Please ensure that application to be get scheduled on that node. Okay, so kind of a scenario. If there is a problem with one room, so I will have maybe created one room backup room. There is a guest room in my home, so you can go and sleep there if there is a problem. If you are not feeling comfortable on this node, so kind of a scenario. Here you can go with this specific unless until it won't satisfy, your pod will be in pending state, but you don't want that. Okay, so in that scenario, we have a concept called node affinity. So you can configure node affinity where you can configure rules. Node affinity in the sense attraction. Affinity in the sense attraction, where you can configure multiple rules, hard rules as well as soft rules. So, node affinity is nothing but same as node selector, but with some permutation and combination. So you are adding, maybe if this rule fail, so there is another backup rule. If this rule fail, there is another backup rule, and you can specify the weightage of your maybe the application kind of a scenario. So there are two rules you have in the node affinity. Node affinity is a conceptual similar to node selector. Okay, so here you're specifying, you're telling that what you want, where you want to see that application. So the first rule is required during scheduling, ignore during execution. So this is same as node selector. So the scheduler can't schedule the pod unless the rule is met. This function is like node selector, but with more expressive syntax. So when you go with this required during scheduling, ignore during execution. So it is same as node selector, and you can have multiple key values. So that will maybe the advantage. The second is prefer soft rule. So here it need to satisfy, unless until it don't satisfy, your application will be in pending state. When you go with preferred during scheduling, ignore during execution, the scheduler tries to find that node. Okay, if a match node is not available, the scheduler still schedules the application on that specific node. So it will allow your application to run on those nodes as well. So now how to specify that? So this is how you add in the pod. In the spec section, you try to add the affinity. Affinity, which affinity? Node affinity. So in the node affinity, you are writing one hard rule. Required during scheduling, ignore during execution. On which terms? What is the node selector terms? What are the labels I need to ensure? The label is, this is the key, and these are the different values. So you can have operators. So the operators maybe like maybe you can have different: in, not in, exist, does not exist. You can have different operators. In, it should be match, maybe one. Not in, it should not match. Exist in the sense, if the key exists, then it is fine, so schedule it. Does not exist in the sense maybe anywhere. Okay, fine. So this is maybe a kind of a different operators you can use: in, not in, exist, kind of a scenario. Now if you won't find any node, for some reason it got failed, then I am telling that, so there is another rule, preferred rule I have added. So the preferred rule is, here I'm adding weight. The one is the lowest, maybe ensure my pod to be running. Okay, the preference is, so here I'm just adding a key value, some random key and value. If it finds, yes, otherwise schedule my application. So the node having a label, another node with the preferred during scheduling, ignore during execution. So it is same as node selector, but you are adding some more key and values by using required during scheduling, ignore during execution. Okay, this is called node affinity, by using which it is same as node selector, but you're adding some hard rules, some soft rules, so that you can utilize your resources as much as possible with maybe some cleverness rather than wasting the resources. Okay, so in the same way, how we have node affinity. So here, which label we are looking to schedule my application? Node label. So in the same way, we have another type of affinity called pod affinity. So here, can you get to see here? Pod affinity. In the pod affinity, what will happen? We will tell, we request, hey scheduler, there is a maybe pod which is running with this label. There is a pod which is running with this label. I want to see all these application to be running on that specific node only. There is already running, maybe, or maybe where this in the group scheduling, kind of a group scheduling. So I want to see all the pods on the same node. So they are interrelated microservices. If they get scheduled on different nodes, maybe I end up having some network latency. So that will be the use case. So in that scenario, I want group scheduling. So all the pods should be running on the same node. In that scenario, I go with pod affinity. So in the pod affinity, it won't look for, I don't have any load label here. I am telling that there is a pod running with this label, team is equal to Asim. Please ensure all other pods should be running on same node. So this is called pod affinity, where we are looking for pod label, not node label. So you can go with yes, pod affinity required. Here I'm telling that there is a pod with which is having a label, a security is equal to S1. Okay, so like that, you can specify, you can run your application by using the pod affinity as well. And you have constraint as well. Rather than affinity, you can ensure, hey, don't schedule my application the node having a label team is equal to Asim. So you can go with that as well. Anti affinity, affinity, attraction, anti affinity is called repulsion, is called repulsion. So you can go with affinity and anti affinity as well. So this is regarding the node affinity, pod anti-affinity, node anti-affinity. So you can go with maybe these methods as well for scheduling your application. Yes. So now the next thing is we can schedule. Now I have some nodes. I have some nodes and I want to reserve those nodes to run some specific applications. I have some nodes. I want to ensure, or maybe I want to run, maybe I want to reserve those nodes to run some AI/ML applications, some different applications. I want to reserve them. What do you think? Is that possible to conserve a node? Maybe I don't want to allow any other applications. I don't want to see any other applications. I want to see this specific application to be running on node 1, node 2, node 3. Yes, that is also doable. Like how my master node is not allowing any application to run. Is it possible to run any application on the master node as well? What do you think? When I deploy a deployment, hey, kubectl, I want to create. What do you want to create? The deployment. What is the name of the deployment? Test hyphen dep and hyphen hyphen image is equal to nginx and hyphen hyphen replicas is equal to 20. I'm just deploying the deployment with 20 pods. Now, hey kubectl get pods hyphen o wide. Can you get to see? Is there any pod running on master node? Is there any instance running on the master node? No. What is the reason? Why it is not allowing? Because it is also node. Is it possible to run your application on the master node? What do you think? Okay, so fine. Master is tainted. Very good. So Yes, you can schedule your application on the master node, but it is not recommended. If you have any business use case, if you want to run any monitoring application on the master node, in that scenario, you can go with this, maybe the scheduling. You can allow, you can deny by using, there is a concept called maybe taints and toleration, by using which you can allow, you can deny your application to run on the master node as well. Okay, so we have a concept called taints and toleration, by using which you can allow, you can deny your application to running on master node, or you can conserve. If they have this passcode, then only I want to allow this application. If they have this specific role, then only I want to run my application on this node. So kind of a scenario, you can do some permutation and combination, and maybe that will, maybe the concept we will take, the concept of node selector, the concept of node name, node affinity, pod affinity, node anti-affinity, pod anti-affinity. So now let's go and discuss about the concept of maybe how your master node is not allowing your application to run. So when scheduling, if you want to reserve your nodes to run, to run your specific application, that is also doable. So how the master node not allowing any application, any generic application to run on the master node, in the same way you can configure the same behavior for other nodes as well. So that's where we have a concept called taints and toleration. So that's where we have a concept called taints and toleration. What is this taints? So taints are applied at the node level. So what is this taints? Taints are applied at the node level. Okay, so taints are applied at the node level. Taint consisting of a taint allow your application, your pod, to refuse to run your application. You can apply, you need to apply the taints on maybe at the node level. Okay, so now taint consists of mainly three things. If you want to apply any node with the taint consists of three things. Three things you have to ensure. One is key is equal to value colon effect. Key, value, and effect. So what is this key? So the key here, you can go with, the key is maybe any string, any value, begin with letter, number, or anything. Key and value. So you can go and use anything. Okay, so any word, team is equal to Asim, or maybe how we have used label, application is equal to demo, any key equals value. And in the effect, we mainly have three things. In the effect, we mainly have three things. One is no schedule, no execute, and then prefer no schedule. Okay, so when you go with no schedule, new pods, maybe when you deploy any new application, new pods that do not match the taint are not scheduled on that node. So what will happen here? Okay, so new pods are not scheduled unless they have the passcode. They need to ensure the passcode. If they have the passcode, then the application you can able to schedule. Otherwise, the application will be in pending state. Okay, so when you go with the no execute, first thing is when you apply this taint, all pods get evicted, get evicted, and later it allows the pod with the passcode. Allow the pods with the passcode. Okay, and prefer no schedule. It's a soft version of no schedule itself. When you go with prefer no schedule, okay, here when you go with prefer no schedule, here the scheduler might be schedule your application on the node having a taint prefer no schedule. It maybe assume that if you have all the nodes with the sum taint, and maybe if some application need to run and the taints are not matching and some bots won't have any passcode, in that scenario the scheduler will tries to schedule your application on the node having a label prefer no schedule. Passcode, yes. Okay, so here it's a soft version of no schedule. It's a soft version of no schedule. So no schedule, new pods maybe are not get scheduled unless until they won't have the passcode, and no execute if all the pods are running. First thing is the pod eviction will happen, and the later he will allow the pods with the passcode. And prefer no schedule, if you won't have any passcode in that scenario, you can able to schedule your application on the tainted node prefer no schedule. So now let me prove all these things first. So now let me delete all this stuff. kubectl delete all -- all. Okay, so just concentrate on the screen. I will prove all these taints with the demonstration. So first let me describe my node. kubectl describe node and grep -i for taints. Can you get to see on the master node we have a taint called no schedule. If you go and request capital A 5 here on the master node cube-master, we have a taint called no schedule. So for that reason, so this master node is not allowing any application. If you remove this, you can able to schedule your application on the master node as well. Okay, so on the node 1 there is no taint, nothing. So now first thing, let me delete this. How to delete this? Hey kubectl, I want to taint. What do you want to taint? Node. Which node? cube-master. Okay, what is the taint you want? This. I want to remove minus untainted. Now if I go and check with the same command, same here on the master node, I won't have any taint. Now, hey kubectl, I want to create one deployment. The name of the deployment is test, and -- image is equal to nginx, and -- replicas is equal to 20. Created. Now if I go and check, hey kubectl get pods -o wide. So can you get to see some application will be running on the master node as well? As last time we won't get to see any application on the master node. When I remove the taint, now I can get to see some application are running on the master node as well. Master. Okay, so now what I will do, hey kubectl. Okay, so now let's apply the taint to the node 2 with the no execute. First let's go with the node 2 and let's me apply the no execute. When you apply the no execute, what will happen? So first it evicts all the running pods, and later it allow the pods with the passcode. Okay, so now hey kubectl, I want to taint. What do you want to taint? Node. Which node? Cube-node 1 and node 2. Okay, so what is a taint? App is equal to Rajesh. I want only the Rajesh applications need to run on node 2, and colon effect is no execute, no execute. So now let me apply this taint, control C here, kubectl get pods hyphen override. All the pods are running happily. When I apply this taint, the pods which are running on node 2, they need to be evicted first. So now let me hit enter, concentrate on the screen. Now can you get to see the pods which are running on node 2 are redeployed somewhere else? Is there any one pod on node 2? Single pod? All the pods are evicted? Yes? Okay, fine. Yes, it is behaving as expected. All pods are evicted. So now let me go and apply the taint called on node 1 app is equal to, maybe app is equal to Shantanu. Let me apply Shantanu. App is equal to Shantanu, and let me go with no schedule. No schedule. So now let me watch to see the effect. So now here, let me hit enter. Tainted. Now can you get to see here? Is there any effect? Is there anything is happening here? Is there any eviction? No. When you redeploy the pods in that scenario, it will affect you. So now how to redeploy? So now let me delete these pods. Hey kubectl, delete pod hyphen all. Because these pods are running under the deployment will self-heal them, redeploy them. So now when they recreated, what is the option they have? Can you get to see what is the option they have? Only one option. All pods are running on the master node. Is scheduler scheduling your application on node 1 and node 2? No. What is the reason? The reason is they have one node have no schedule and another node have no execute. So now let me taint master node. Let me taint master node with prefer no schedule. Prefer no schedule. Okay. So now it should be master, and I want the application should be the Maya application to be run on the master node. Master Maya. Okay. Prefer no schedule. Now let me hit enter. Tainted. Now on all the nodes we have a taint, no schedule. No, maybe on the master node we have prefer no schedule. On the node 1 we have no schedule. On the node 2 we have no execute. Now in this scenario where they get scheduled, if I delete all the pods, kubectl delete pod hyphen all, on which node they get scheduled now? Where is the option? kubectl get pods hyphen o wide. Again they rescheduled on the master node only. Okay, so this is how maybe you can. But Mudassir, how to ensure my application to be running on the tainted node as well? If it is tainted, I don't want to remove. So how to run my application with the passcode? What is this passcode? So the passcode is nothing but your toleration. So now the passcode is nothing but the toleration. So tolerations are applied at the pod level. In the pod YAML manifest, you need to ensure the toleration, and then you can able to schedule your application on the tainted node as well. Toleration. This is how you can ensure the tolerations. So now here vim.pod.yaml, I'm just going tolerations. I need to add. So here, if you want to ensure your application on the tainted, okay, taints and toleration, fine. So in the key, what I have to specify? So the key is app equal, fine. What is the values we have? Values. If you want to ensure that application on tainted node, on the node 2 we have app is equal to Rajesh. App is equal to Rajesh and no execute. Okay, so now here, okay, now I'm just changing the name. Now let me apply it. Hey kubectl apply -f. If everything goes smooth, it will be running on node 2. Otherwise, okay, got it. There is a indentation error. Okay, kubectl apply pod.yaml. So now if I go and check, hey kubectl get pods mongo 1, it is running -o wide. Can you get to see your application on running on node 2? Can we able to add the toleration? Okay, so to understand this concept easily, Rajesh, I usually give an analogy. So in India, we usually use good night. What is the use of good night? Mosquito repellent. Okay, when you we switch on the mosquito repellent, somehow 1 or 2 mosquitoes will be roaming in your home. 1 or 2, not all. Yeah, and so why can able to roam? Because you have the repellent. That mosquito will have the resistance to that repellent. He can able to tolerate that. Am I right? Okay, so now in this analogy, who is taint, who is toleration, and who is pod? Who is taint, who is toleration, and who is pod in sense of good night? Mosquito. So taint is nothing but your good night, and pod is nothing but your mosquito. Yeah, and toleration is nothing but mosquito will have the resistance to tolerate that repellent. Okay, so that's how you will ensure your application to get scheduled on specific node by using this taints and toleration concept. If they won't have the toleration, so in that scenario your application will be in pending state. Got it? So the concept of taints and toleration.
Alright, today we explored manual pod placement, label-based scheduling with node selectors and advanced techniques like affinity rules and taints tolerations. You now have the tools to optimize pod placement, trying applying these concepts in your own environment. And if you have any questions about the implementation of these in your projects, put them in the comment section below and we will see you in the next tutorial.